Hello and welcome to our first lecture. I call this lecture A Journey to the End of the Universe. My name is Ran Sivron. I'm a physics professor from Baker University and I'm the teacher of PC 140 Astronomy and online course. This first lecture is very different than the rest of the lectures that we have in this course, in that every single slide has some information. That information is not unique. You can find it on Wikipedia. What's unique is that in every slide I will also ask a question. Most questions will be how. Basically, how do we know that specific fact? Throughout this course you will see that science is all about how. How does each and every person find out information, not what it is that we know. This is how we built our best tool ever, the tool called science. At the bottom of the page you will find a link to a musical accompaniment. Usually what I did is that I included something from YouTube, usually a song or a musical instrumental piece. Usually I do that in order for you to think about our next upcoming topic. The first one is fairly straightforward. Second one will be a tad less straightforward. Try it. My guess is that you recognize this picture. Yeah, that's Earth, obviously. This is a picture of Earth taken by Apollo 11 astronauts on their way to the moon. To us, it is obvious that the Earth is round, especially because of pictures like this one. But how? How did we come up with a spherical shape? How have we proven it many years before space flight was available to us? How did we use this information, for example, in finding America? This is the moon. You can go, duh, of course it's the moon. Let me ask you an English question. What's the origin of the name moon? This will actually tell you a little bit about what we learned about the moon and how we figured things out about the moon. Of course, this is the sun. On the right hand side, in the visible part of the spectrum, you may notice the sunspots on it. On the left hand side is a picture in the X-ray part of the spectrum. By now we know that the sun is a nuclear furnace. In its center it works using fusion of hydrogen into helium. How do we know that? This is a picture of the constellation Orion in the night sky. In the summertime months, it's only observed very, very early in the morning. Every single star that you're seeing is similar to our sun. How do we know that? Actually, not all the stars are exactly like our sun. For example, the star on the upper left corner, called Betelgeuse, or we better know it as Betelgeuse, is a red giant star. If it was placed in the place of our own sun, it would encompass Earth and Jupiter, and we would all be pretty much scorched. How do we know that? I'm going to ask you a question about those 5 pictures. Try and order them in youngest to oldest in the life of a star? Okay, let me give you the answer. Of course, throughout that answer you should ask yourselves, how does he know that? On the upper right is a fairly nebulous cloud of gas that's illuminated by other stars. This could in principle be a region of the sky where new stars will be born, but not necessarily. Middle bottom is a place called the Pillars of Creation, because this is a place where stars are being born. Maybe a star nursery, if you may. On the left is a region of the sky with middle-aged stars. One of them actually harbors an X-ray source, which is a black hole. On the upper left is what's called the evil eye, or a planetary nebula. This is what happens to a star near the end of its life, depending on how massive it was to begin with. On the bottom right is a picture of an accretion disk near a white dwarf or a black hole, or maybe a place where stars are being born as well. So unplaceable in terms of its time. In a picture below you see a panoramic view of the whole sky surrounding us with the gamma ray telescope called the Fermi Laboratory. The stripe in the middle of the picture is our own Milky Way, and we are inside that Milky Way. How do you know that? Two or three of the dots in the picture below have crosses on them. Try and find them. The rest of the dots and blotches and blobs do not have crosses on them. Each and every one of these is a galaxy like our own Milky Way galaxy, and has hundreds of billions of suns in it. Obviously the question should be asked, how do we know that? The Big Bang Theory has been supported by 5 independent proofs. Of course, what I mean by the Big Bang Theory is the fact that the universe used to be much denser and much hotter about 13.7 billion years ago. Anything beyond that fact is gonna be very, very hard to argue. But still, that first hypothesis that has now been supported so many times begs the question, how did we prove that the universe was so hot and so dense in the past? The how questions have been answered, at least in part, by instruments that we have been using at least since Galileo, called telescopes. In this slide I'm describing a few of those telescopes, from an earth-bound refractor to space-bound multi-telescope observation schemes. The best way to find out about astronomy and the stars is to reach for the stars, and the people that reached the furthest have been our astronauts, both by visiting the moon and by placing telescopes and other instruments out in space. Those astronauts have been reaching for space since the early 1960s, and some of them have paid the ultimate price. In the pictures that you're seeing below are Apollo 1 astronauts, the Challenger astronauts, and the Columbia astronauts that paid with their lives in reaching for the stars. Maybe the main reason that science is such a powerful tool is that over the last 2500 years we have learned to ask the correct how questions. Hopefully, this will enable us to answer some of the questions that I have outlined below. See you in the next lecture.